at Ceres in Carolina.
Okay, am I in control of the slides, or do I just ask them to be?
Just ask for next.
Okay, so I'll be giving you an update of Donna at Ceres. Next, please. So as everybody I'm sure knows, the mission ended on October 31st last year, and we collected valuable science data up to the last drop of hydrazine. And the data set that was collected in the second extended mission is really interesting, valuable new data. So the team and I think the external community is very excited about them. There are some new features on the website that were created from these new data sets and overviews of the mission itself. So encourage you to go there as these are resources for teaching or your own information. So we are headed towards project closeout the end of March of 2019, and focuses obviously on archiving all the remaining data and publishing the results of the second extended mission. Next slide, please. So on the next couple of slides, just give you a sampling of some of the features that are up on the website. This one is there's a sidebar here that gives you kind of an overview of the highlights of the entire mission and so forth. Next slide. And we participated in a science chat that was organized by NASA. This is a new format that they're very interested in continuing, and this is a video chat, goes out on YouTube and social media and allows interaction with social media users and the media. And I think the chat went very well and has been widely viewed. So this looks like a very useful and effective way to get information out very broadly, and I think it's already in use for other missions. I think there was one for OSIRIS-REx as well. Next slide. Okay, so this is actually an animation. I don't know if it's going to work. Okay, next slide. I should say this is yeah, we'll go back to that, or I'll talk about that later. So where we are relative to the publications, we have 5 special issues. 3 are already published, 1 in MAPS, 2 in Icarus, all of the geologic and compositional mapping results, and then the interpretation of the compositional variations on the surface and how that relates to the interior is in the MAPS issue. 2 in progress, 1 looking in detail at the Uvara Crater region, one of the most interesting regions on Ceres, which was shown in that last slide. And this issue is wrapped up and will be published in March. And then 1 in progress in JGR on features related to ground ice. We are working on the papers for the results of the second extended mission and getting ready to organize those into a journal. And finally, there's some discussions ongoing for a book on Dawn mission results, and Simone is taking the lead on that. Next. And there's a couple of highlights, this one and the next couple of slides on recent publications. This by Mike Sori on looking at domes on Ceres and then modeling what the rates of volcanism would be if we assume that these domes are features like Ahuna Mons that have now relaxed and degraded over time. So he took mapping that Hannah Sizemore had done of all the domes on the surface, and then did this inventory and assessment and came up with some cryovolcanic extrusion rates, and that's shown in the bar chart on the left. Next. This recent paper by Simone considers the surface composition, the fact that it looks like altered CI chondrite, and that the low iron content and the higher weight % of carbon suggests that there is significant carbon within the regolith. So, and that this carbon is not being detected by the spectrometer, except in the one instance of Uvara Crater, because it's mixed in with the surface and it's difficult to detect. But the elemental abundances are telling us that there's likely a significant amount of carbon, and therefore that organics were being produced and during this global alteration process. So there's an interesting cartoon on the right that tries to get across the idea of these complex processes which were occurring in the series regolith and upper crust during alteration. Next. And then finally, this study by Kai Hewson, who is finishing his PhD at UCLA, examined the sets of normal faults in they're called Narsulcus in the southern hemisphere of Ceres, and these are indicative of a thin 3 to 10 kilometer mechanical lithosphere or elastic lithosphere that's being deformed, and implies a fairly high heat flow during formation of about 10 watts per meter, and that's much higher than we would expect for Ceres global heat flow. So it's just an interesting conclusion that needs to be followed up to really understand what it's telling us about the interior of Ceres. And the interesting analog is that it's similar to what is seen on icy moons. Next. Yeah, this was an animation too, but animations don't seem to be working. So then quickly, just the results of our XM2 mission. These were the science objectives. I've been over these before, and then we had 2 phases. The final was this very low periapsis elliptical orbit where we got very high resolution data. And we were trying to map the abundance of elements at the scale of regional units, and also look at the distribution of the ammonium species hosting ammonium in the southern hemisphere. Also, the detailed geomorphology and composition to help us understand the processes which are driving the cryomagnetism that we're seeing. Next. So here is an example of the results obtained for the gamma ray neutron detector. This map is background is showing you the major geologic units on Ceres, and the sort of cone of circles is showing you the full width half max resolution of the grand instrument as the orbit is sweeping down and approaching the surface right over the Uvara Crater, which is that a reddish circle in the middle. So this is just one instance, one portion of this orbit that had that was precessing in longitude from north to south through the longitude sector, which included the Uvara region as well as Uvara. So that kind of resolution marched from the north to the south during the campaign. And over on the right, you can see the counts, which are showing you the relative variation in neutron absorption as you're going across that swath. And marked here are the boundaries of the Uvara Crater and its ejecta blanket. And one can see that there are large variations in neutron absorption, which are interpreted to be variations in the hydrogen content of the subsurface. So these results are being worked up now into a paper that will be included with the initial results special issue. Next. And then finally, we got very high resolution gravity data along this longitude swath. And I like this map because it really gives you a nice visual on where the new high resolution data are. This background, kind of bluish-gray, shows that the overall degree strength of the gravity data for series globally is about degree 20. And in the XM2 swath, we got up to degree 49. So these data are still being finalized, but we expect to see some very important, we'll be able to make some important inferences about the density structure beneath these really interesting features on the surface, the Okata region. This is across Hanami Planum, which is the highland region of Ceres, which we think has thicker crust, and then across Uvara Crater. Next. Okay, so finally we'll just do the standard tour of all these high-resolution images that we got as we crossed the Okata Crater region. I'll mention here that the team did a trajectory maneuver and very carefully targeted the Vinalia Faculty, which we're looking at right here, and they were successful in getting the highest resolution possible over that feature. So this was really a very important success for XM2. And then here you can see that the bright material, which is dominated by sodium carbonate, but also includes ammonium chloride, has some deposits which are filling in cracks in the central pit structure, and then a large dome, which we believe is the youngest feature in the crater. And interestingly, the dome does not have any flow boundaries relative to the underlying deposit. So that's a very important clue as to its origin. And then over at about 7 o'clock, you see this isolated bright feature, and we'll see that again, but it's an isolated deposit on a ledge on a massif, which is part of the central peak complex. So there's 4 panels on this slide if we walk through them. Here showing the kind of interesting details we see with more competent material in the regolith and the fractures and distribution of bright material. Next. And here again, we see over and over again this kind of more competent material outcropping on the crater walls, and a lot of mass wasting occurring related to that. Next. Fracture networks came into high relief, and lots of details in these networks, which are being interpreted in terms of the tectonics and the ongoing deformation, both from the mass wasting and from what we believe is pressure from below of material that's being intruded into the floor of the crater. And finally, this is a close-up of that perched deposit, and you can see the interesting tendrils of bright material which are sort of flowing down the slope, and that this deposit is fairly thick and isolated or distinct. So this is something that's being heavily debated as to its origin, and is certainly telling us something important about the overall emplacement of the bright material and the process. Next. And then just another couple of really cool images showing the kinds of mass wasting features and giving you an idea of kind of the overall strength of materials and the distribution of the bright material, the fact that we see it's mixed in across the, really ubiquitously in series, and will outcrop in these areas like you're seeing in the right panel. And then next. And the last series here is on Vinalia Faculty. And this is series of bright spots over on the eastern side of the crater, and they were they looked quite interesting, but most people would focus on the very bright Vinalia Faculty, but it turns out that the Vinalia Faculty are extremely interesting and helpful in understanding the processes, because we believe these are the youngest features of bright material deposits on the surface. So as you can see here, without going into a lot of detail, there's a relationship between the bright material and fracture networks. There's a lot of structure in the bright materials, and we now have also very detailed topographic maps over this area, because we were operating the two cameras simultaneously, which we had not done before in the mission because of the need to preserve one camera for navigation purposes, so they weren't considered redundant. And we were able to use them both and get high-resolution stereo. So now we can really understand the superposition relationships and the structure of these deposits. So again, very important and valuable data set. Next, a couple more close-ups. This is a recent crater exposing very dark material, which is, we think, one of the most recent deposits. And it's very close to a center that looks like a newly extruded deposit of bright material. Next. Close-up of that central complex and seeing the interesting geomorphologic features and the enigmatic trough of dark material surrounding this little square of bright material in the center. Still, we're still discussing that and trying to better understand how that formed. Next. And then here, finally, a close-up of the fracture that's just below that, that square feature. And here you can clearly see that this fracture was likely reactivated after the deposition of the bright material. And we see a good example here of the bright material flowing downslope into the fracture. And that's something that's seen quite often. And next. And then Uvara Crater is one of the three large craters on Ceres, and this one has a very interesting central ridge complex, and we got very high resolution data of this as well. So it's also a focus of our study right now. And I think that's probably all for the images. Nope, one more. Okay, so on the left side, these are the fractures on the floor of Akator, and again, probably indicating some force from below. Next. And mounds, and one more. Yeah, okay, we'll move on. I see Tim probably wants me to hurry up. Quickly, the data archive status. Ceres archive is complete for the primary and the extended mission 1. The data from XM2 are on track to be delivered to PDS next week, so we're in good shape. And then we'll be moving all the data to PDS4 format following that. Next. So summary, we got the data we intended in XM2. We're going to be talking about that at LPSC, and you can find the data in the PDS. And then I think I have 2 more slides. Simone may be talking about this, but just FYI, there's a workshop coming up, and you can find the information at the website below. And then finally, Simone found this feature on Ceres, and I think it's a good segue into his talk. Thank you.
Okay. Thanks, Carol. I think we have time for one quick question, if we've got a quick question.
Anything online?
No mind. All right, thank you. And then